with that the issue. So I'm going to show you one very important thing. Probably we are not going to talk about. We are not going to talk about this thing in any other place. But just right now, as it seems, this is the relevant point to learn this. As we discussed about this linear mass density and the area mass density and the volume mass density, it seems this is the best point for you to just learn this the upcoming fact. Now let's say, for example, the one object is there. Let's say that object is a rectangular object, okay, something like that. And now at the same time, that object is immersed in a liquid, right? Something like that. And at the same time, the immersed, so to that level also. So in the surroundings, what do we have? That's the liquid, and this object is immersed inside the liquid up to a certain extent. So meaning this object is partially immersed. Partially immersed in this liquid. Sir, can we immerse the object completely or fully? Of course, yes. I mean, then, sir, will the principles we are about to discuss be held true? Of course, yes, my brother. So what we are going to talk about, this particular situation will be held true even when the object is completely immersed inside the liquid. So therefore, it's going to be kind of like a theory. Theory we are about to discuss. Something we are about to discuss. A theory which is equally valid, equally held, equally applied to a situation where an object is partially or just the only by portion it is immersed or fully. So we say completely immersed or fully immersed or partially immersed, right? Fine. So now, what would be the amount under that liquid? Okay, that's going to be that. So let's say that shaded amount is going to be the one. The shaded amount is going to be the area under the water, under water or under liquid. Let's say just in this case it's going to be water, right? Right, fine. So here it's going to be water. I'll just write water. Water is the most abundant liquid, and density of water is going to be a rho density. This object's volume, the volume which is below liquid level, volume below liquid level, the volume of the object which is immersed or which is inside the liquid is V. So now should not get confused that V is not the entire volume of the body, not the entire volume of the body. That is the amount of volume which is immersed inside the liquid. So in other words, that much volume is inside the liquid. So the same amount of volume of the liquid has to get displaced. Okay, I'll repeat one more time. This is the volume of the object which is under the water level, which is going to be inside the water, So thereby displacing, very important, displacing the same amount, same volume of water. For example, let's say the one of you just put your hands or your legs into a pool. So what's going to happen? The liquid molecules which were there in the volume occupied by your legs are now displaced, because that volume is now occupied by your legs. So why legs can occupy that volume? because the liquid molecules or water molecules which were occupying that volume have got displaced to somewhere else right now. Okay, this area. So that that volume V is going to be the volume of the object immersed inside the liquid, or we can just refer to that V, or just can write for V as the volume of the liquid displaced, right? The density of the object, very important, density of the object is going to be, let's say, simple D. That's the density of the object. So for example, let's say this object is one of the wooden rectangular block. So this simple D stands for the density of the wooden block, or density of the wood, not the density of the water. But here rho is the density of water, not the density of wood. So therefore, make the distinction between two densities, right? And that's going to be the water level, and that amount is going to be up. So now the object is floating, right? It's called actually floating. Object is floating. So we say object is floating. That one is floating in equilibrium. Object is floating in equilibrium. What do you mean by equilibrium? Object is not acted on by a net force. Floating in equilibrium. Something is floating in equilibrium. Just like let's say, for example, a ship or probably a boat. It is just on the sea. Part of the boat or the ship is inside the water level, and part of the ship is going to be outside the water level as well. But that ship is in equilibrium. That is why it is not going to go further down, or it's going to go up further, right? So it is in equilibrium. So what are the forces acting on this particular object? One is going to be its own weight. We know that's acting from where? From the center of gravity. So it's going to be a vertical force like that, right? Okay, fine. It's going to be center of gravity. From center of gravity, that weight is acting vertically downwards. Let the mass of the entire body to be something like simple m. So therefore, weight is going to be simple m into g. Now there should be another force to cancel that weight. That's why object can be said to be in equilibrium. So particular force should be definitely vertically upwards. This force, let's just give it a name. U. Just say that what's called this name of that force is U. My question is, in order to cancel this weight mg, which is a vertical force, it is known to you now, I mean already, weight is acting vertically downwards. I mean, Earth is pulling each and every object in its gravitational field towards the center of the Earth. Towards the center of the Earth is the one which is vertical. Towards the center, vertically downwards. Away from the center, vertically upwards. So we are projecting one particle into the space. So we say just like this. A vertical velocity is given, but it is that particular velocity is given away from the Earth's center of the Earth. So we say object is projected vertically upwards. This area. Okay. So therefore, there should be a force because it's equilibrium now, that weight cannot be there. In case only weight is acting on the block is going to sink. You will be able to find that block not on the surface, not somewhere there here in the mid. Okay, probably on the seabed or the bed of the river, something like that. at the bottom of the whatever the pond or the lake or whatever, right? So why it is not going to either sink further or it's going to go up? Why it is not going to sink further or not going to go up? Because that mg is getting cancelled by a force. So in order to cancel mg, as mg is acting vertically downwards, that new force, new in EW, new force should be vertical. Why? Because mg is vertical. Therefore, this force should also be vertical. Oppositely directed vectors can get cancelled. That's the idea. At the same time, they should have equal magnitudes. Obviously, right? Fine. So therefore, magnitude of this vertical force, the weight, is mg. So therefore, that u should always be equal to the weight of the object if it is floating in equilibrium. Understood? Eh? Fine. Okay. Then so therefore, basically, u, the force which is acting vertically upwards, is equal to mg. Mg is going to be the weight that is equal to the body. There is no problem regarding that. That is equal to the weight of the body which is acting vertically downwards. But that u, regarding u should be vertically, you should be a vertical force, and it should be upwards. Why? Because it is there to cancel that mg. If it is also downwards, they both are getting added together and will make that sinking process much rapid or more easier. So therefore, this u should be along the opposite direction to that of the weight of the object. So it's like a vertical force u is a vertical force and should act vertically upwards. And the u is planning to cancel that mg. So definitely it should have, u should have the magnitude of mg. For example, let's say mg is going to be 10 Newton. U should also be 10 Newtons. Then and then only two forces are getting cancelled with each other, and therefore object is not acted on by a net force, and which gives the room for the object to be in equilibrium. Understood, right? Okay. So therefore, we can just write here the u is equal to mg. Right. What is u? That is called upthrust. That u is called upthrust. Understood, right? That's why actually u is there. That u is called upthrust. Oh, there's another force for you. The word for you. Buoyancy force. Be careful when I'm going to write that. Even the teachers, does the wrong thing. They also sometimes misspell this word, buoyancy, right? So you don't have to worry because I'm not a teacher. So no worries regarding that. Pretty sure that spelling is correct. Buoyancy force. That is also called buoyancy force. Therefore, buoyancy force is the one, okay, which is symbolically represented by u. Right. So upthrust is also known as buoyancy force. Now, then this upthrust is given by a law called Archimedes' law. Probably you have gone through this in your O-levels, but the point is sometimes for the time being you have no idea about that. Anyway, I'll just revise that, right? What is meant by exactly what is meant by the Archimedes law. Now, an important point is Archimedes law is related with this particular force called upthrust. Why it is called up? Because it's always vertical. Why? Because I told you that purpose force is to cancel that object's weight. In order to cancel the vertical weight, force which is going to cancel that vertical force should also be vertical, up. Meaning, it's not downwards, it's up. The force is the one which is on up thrust. That's the idea. Okay. So therefore, up thrust or the buoyancy force is always something which is vertically upwards. Why it should be vertically upwards? In case one of your friends is going to ask from you, why up thrust is to be always vertically upwards? Why I can't mark that thing a little bit inclined? Then you can answer, or just explain him, convince him or her. If the up thrust is going to be inclined, then what? The purpose of that, entire purpose, that's the most important thing, entire purpose of that up thrust is not to cancel the weight. Because if it is inclined, it can have two components, one upwards, the other horizontal. Like two components like this, one upwards, the other one horizontal. Probably this vertical component can cancel the weight, but this force will remain. So meaning what? It is to move that. I think it's smart thing. You just place a ball on top of horizontal water surface. Ball is moving. Ball is moving. So we don't want fuel like petrol. Gasoline, like the petrol or diesel or some kind of engine in a boat or in a ship for them to move, because that horizontal this vertical thing is cancelled by the weight, but yet that horizontal component will be there. Then they can move along that direction. So which is completely against the law of conservation of energy, because there is no work done, but actually movement is there. Movement is there means some kinetic energy is there, but nobody can be seen who gave that kinetic energy. So therefore, it's like energy has been created, which is not going to happen in our physics. In our physics, energy can be neither created nor destroyed. The definition of law of conservation of energy, or just we can say energy remains constant inside a closed system, or we can say the total energy of an isolated system is constant. In case you will ask from me, so what is meant by this isolated system? For example, our universe. So our universe is going to be one system. The problem is that universe was created when, how, and what is going to happen to that universe. All these things are going to be additional problems. For the time being, I'm not going to direct into these problems, because they are a little bit messy. At the same time, they demand much more understanding about the physics. So therefore, let's leave that thing for the time being, as it is not in the direct importance of our journey. Okay. So therefore, if you take a universe as one system, right? Let's say 100 joules is getting dissipated, but that 100 joules is going to appear at some other place. So therefore, if somebody is looking at the universe, probably just assume, right? All these things are virtual. I'm asking you to assume. Okay, do like this. Likewise, just to make the journey easy. Let's say universe is there. So inside the universe, somebody is going to pluck one mango from a mango tree. So actually, he plucked the mango means mango tree lost some amount of energy. So somebody who is going to look into that mango tree might say, "Oh, energy is destroyed." No. Why? Because the person who plugged that, who took it, ate that thing. Or probably he is holding that thing in his hand or her hand. So that amount of energy is going to appear at some other place. So the one who is looking into the mango tree as well as the one who got that mango, both mango tree and the person. So mango is there. What happened? Mango, just the mango changed its place. Very important. It was with the tree, now it is with the person. So likewise, energy can only change the place inside the universe. It can move from one place to another. Usually we say it is getting transformed. It is getting transformed from one form into another. That's all what is going to happen to that mango, the amount of energy. Mango is holding, let's say, for example, let's say 10 joules. So tree lost 10 joules. That person is going to consume that mango. So that person is going to get that 10 joules. So 10 joules now is not the tree, but 10 joules is there with the person. So when you take the tree and the person both together, yet it is going to be 10 joules. I mean 10 joules is not lost. So that's what we said. The 10 joules can neither be created nor destroyed. It is always there. Only can be transferred from the person to the mango tree, from the mango to the person. Likewise. Then transition is the only possibility. Not the creation, no destruction. Done. Okay. So Mahapada upthrust. Anyway, this upthrust is the particular force called upthrust is usually given by something called Archimedes law. One very important laws, right? No need to know or come to know about the details of the Archimedes laws, right? But I want you to be 2-3 steps ahead than your colleagues, contemporaries, your friends, right? Your colleagues, your classmates. So therefore, knowing what is meant by Archimedes law is something really important to make you like a giant in the subject. I mean, somebody who has some understanding than expected, demands some understanding what is meant by Archimedes law. Even though we are not going to bogged into details, we don't want very deep details, but something lying on the surface. Right, fine, okay, we are back on track. What it says, I mean, actually, we find Archimedes laws. Archi. So CHI, just write CHI, Medes law, MEDE'(S) law. Archimedes law. Mahapada, that Archimedes law states, I mean, that law says the upthrust or the buoyancy force, upthrust or the is equal to the weight of the liquid displaced. So if I write here, U is equal to the weight of displaced liquid. Very important. The weight of the displaced liquid. Then in this case, liquid is going to be water. So if I write liquid, now Mahapada should be able to understand this is not only held true for water. It is held true for any liquid, even for mercury, which is the only liquid, which is the only liquid state of a metal which can be found in the room temperature. Only solid which is existing in the phase of liquid at room temperature. So therefore, this mercury. If it is a liquid, it doesn't matter whether it is whether it is going to be a metal, or whether it is a conductor. I mean, or it is a semiconductor, or it is an insulator. This is material as far as that particular body is going to be in liquid form. Is it liquid? yes, then Archimedes' law is held true. That's the point, right? Fine, okay. So now, if we take that weight thing into account, so displaced volume is very important. Is the weight of the displaced liquid, right? Is something really important thing here. The weight is important. Weight of the displaced liquid. Weight of the displaced liquid. Displaced liquid. Right. Now go back to the figure. So I'm going to ask one small question. Just answer. What is the displaced volume? Say why? Because the volume of the object, which is underneath, which is inside the liquid level, is going to be V. So therefore, the liquid volume which got displaced by the object is also the same. Obvious. So therefore, liquid volume displaced is going to be V. But the point is, they are asking about, Archimedes' law mentions the upthrust is given by the weight. So weight means mass into acceleration due to gravity. So therefore, right, fine. So if the displaced liquid volume, if I say just I'll draw the thing by using a different color, because of this object, let's say displaced liquid, some amount of liquid got displaced, right? Liquid, actually it's water in this case. That particular liquid has some mass, some amount of actually V much liquid got displaced. That particular liquid volume has some mass. Let's say that mass is going to be something like capital M, right? Simple M is the mass of the object, the body. Capital M is the mass of the liquid volume displaced. Now, what would be the weight of that displaced mass of the liquid, or just the mass of this displaced liquid is going to be capital M. Then, according to Archimedes' law, the weight, then weight is given by mg. So therefore, I have to get that mass capital M here, and to be multiplied due to gravity. Mass of the liquid into actually mass of the displaced liquid into acceleration due to gravity. Then one of the important points where we have to just replace mass by using volume and the density. Now if I say if I take that displaced, okay, fine, here just a small thing, displaced liquid. If I that big, the volume displaced is equal to the volume which is volume of the object or the body which is underneath the water level, liquid level, which is V. Then mass of the displaced liquid is going to be capital M. We took that in be capital M, that's all. So density of the displaced liquid is also just the same density, is going to be rho. It got displaced, but density, there is no reason for the density to get changed. The same liquid, water, surrounding water, and the same water was there, same liquid was there. The liquid is the same type, same liquid, water is getting displaced, so same density there. Fine. Now how these three things are getting interconnected? Fine. As we defined in the last whiteboard, the whiteboard we saved, density is defined as mass divided by volume V. So I can just make a mass. Therefore, that mass simple m the subject by taking this v here is let's say v into rho, the product. Another important thing, this is what we proved last time regarding volume mass density or simply density. Now, this mass, okay, the mass of the displaced liquid can be replaced by the brown color, by this product, rho into E. Okay, so I'm going to do that. So what I'm going to do is I'll just take that block here, is here, right, that one. So can be used all the way up to there to replace that capital M, right? Fine. So therefore, being back on track, I can just write that is going to be equal to, therefore, instead of capital M, I can write V rho dot, that's capital M, G is there, outside. Okay, that's V rho G. So therefore, that very important relationship, okay, fine, upthrust U is given by the expression V rho G is getting immersed. That's the point. Right. So now, when I just explained when I was explaining my Buddha in last the screen, the Puthalame, sometimes we happen to express mass in terms of density and the volume. Probably probably you are thinking, sir, I mean, if we can go through an application, it will be much easier to remember or be really relevant. Like, I think I did one example, but actually one of the important theories in your the career in physics, at the same time to keep you little ahead than your colleagues, right? So therefore, here that's the point we used, that mass is the of the volume and the density. So once we replace that, we're going to get that general expression, general equation for the upthrust. Upthrust is equal to V rho G, volume of the liquid, density of the liquid, acceleration due to gravity. That's something really important. Now, that's regarding the liquid. So we again are emphasizing, right? Because sometimes in the exams, more than 80% can go wrong because they get confused between the volume of the liquid and the volume of the object. Those are two different things. Volume of the object includes the volume of the body or the object which is outside the liquid level as well. But that is not contributing to upthrust according to Archimedes law. The volume which is inside the liquid level, that's going to be V. That is the volume of the displaced liquid, or the volume of the object which is inside the liquid level, water level. And another important fact is the density of the liquid. It is the density of the liquid, or let's say in this case water. It's not the density of the object, which is D. Right. Okay, I think that's explained. And at the same time, this density of the what's called this object, I mean, can be used to express the mass of the object. On the other hand, for example, density, if we take the density of the body or the object, density of the object rho is equal to mass of the object m over entire volume of the object. Let's say that's going to be something like probably V naught, volume of the O object, right? I just got that O. Here is going to be V naught. Actually, V naught means VO, V object. Now, if I make that simple m the subject, so simple m, mass of the object, the body, is going to be equal rho into V naught. Rho into V naught is there. So likewise, if you want, you can express the mass of the body like that. Mass of body also by using its own density and volume. Right. Here this D. Right. So as it might cause the confusion, I'm going to just put that row away. Let's say here also that thing away, and let's say density simple D is defined as mass over volume. Here also that comes up to be the density of the object. So it's the mass of the object, density of the object, volume of the object. Here mass of the liquid, right? Here, so here this portion, mass of the liquid V, density of the liquid rho. That's it. Fine. So this is called the upthrust or the buoyancy force, and that upthrust or the buoyancy force is given by the Archimedes law, which states that so-called upthrust or the buoyancy force is given by the weight of the displaced liquid, right? In case just remember, upthrust is a vertical force which is always acting vertically upwards, and its magnitude U is given by the product V into rho into G. What is V? The volume of the displaced liquid, or the water, or whatever that liquid, right? Into the density of the liquid again, into free acceleration. Gravity is going to be 9.81 meters per second square. Right, that's the regarding upthrust.